Here's a statistic that's been dominating headlines for months. AI uses 15 times more energy than a Google search. 15 times! That sounds absolutely damning, doesn't it? Every time you ask ChatGPT a question, you're supposedly burning through the energy equivalent of 15 Google searches. Tech critics are having a field day with this number. And honestly, I don't blame them. But here's the thing, and this is why you're going to want to stick around for the next 20 minutes. That statistic is not just misleading, it's fundamentally wrong. Not factually wrong, mind you, but wrong in the way it's being interpreted and applied. What if I told you that when you account for the actual work being done, AI isn't 15 times less efficient than Google search, it's actually 30 times more efficient than humans at complex research tasks? What if the energy comparison we should be making isn't between AI and a simple search, but between AI and the total human workflow it's replacing? That 15x statistic? It's like comparing the fuel consumption of a bicycle to a cargo airplane without mentioning that the airplane is carrying 200 passengers and their luggage across an ocean. Welcome to Mindcast. I'm your host, Will, and today we're diving deep into one of the most misunderstood debates in technology right now. By the end of this episode, you'll understand not just why everything you think you know about AI efficiency is backwards, but why this represents one of the most significant leaps in knowledge work productivity that we've seen in our lifetime. I stumbled across this research while doing my own deep dive into AI energy consumption, and honestly, it completely flipped my understanding upside down. We're going to walk through 3 key insights that will fundamentally change how you think about AI efficiency. First, we'll explore the fundamental flaw in how we're measuring AI efficiency. Why comparing AI queries to Google searches is like comparing apples to space shuttles. Second, we'll unpack the shocking reality of what happens when you actually include the energy costs of the human researcher, their metabolic energy, their hardware, their time, and how AI agents are actually 4 to 30 times more efficient than humans for complex research tasks. And third, we'll look at the broader implications of what this means for the democratization of expert-level research and knowledge work. This isn't just about energy efficiency. This is about a complete paradigm shift in how knowledge work gets done. So let's start with that misleading 15x statistic and why it's been leading us astray. Let's start by understanding where this 15 times number actually comes from, because the origin story is crucial to understanding why it's being so badly misapplied. The 15 times comparison comes from early studies that looked at the computational cost of running a large language model like GPT-3 or GPT-4 versus the cost of executing a traditional Google search. And from a purely technical standpoint, this comparison is absolutely accurate. A Google search consumes about 0.3 watt-hours of energy, while a typical LLM query consumes about 4.5 watt-hours. 4.5 divided by 0.3 equals 15. The math checks out. But here's where it gets interesting, and this is the first key insight. These two systems are performing fundamentally different types of work. When you do a Google search, what are you actually getting? You're getting a list of links. That's it. Google's brilliance lies in pre-computation. They've already crawled the web, built massive databases, and indexed everything. When you search, they're just doing a lookup operation, finding pointers to information that already exists in their database. It's incredibly efficient, but the cognitive work of actually reading, analyzing, and synthesizing information, that's externalized entirely to you, the human user. Think about your typical research process. You Google something, get 10 blue links, click on 3 or 4 of them, skim the content, maybe open a few more tabs, cross-reference information, take notes, and gradually build up your understanding. Google gave you the starting points, but you did the intellectual heavy lifting. Now let's talk about what these new deep research agents are actually doing. Systems like OpenAI's Deep Research, Google's Gemini Deep Research, or Perplexity Pro. These aren't just doing database lookups. They're performing what the research calls agentic workflows. They're planning, searching, reading, analyzing, and synthesizing.
Here's how a deep research agent actually works, and this will blow your mind when you realize the scope of what's happening behind the scenes. First, there's what they call the reasoning engine. When you give it a complex research question, it doesn't just immediately start searching. It thinks. Systems like OpenAI's O1 or DeepSeek R1 generate thousands of internal reasoning tokens, essentially having an internal conversation with themselves to understand your question and develop a research strategy. We're talking about 20,000 characters of internal reasoning before they even start executing searches. Then comes the information foraging loop. This is where it gets really wild. The agent doesn't just do one search. It executes 20 to 50 unique search queries, often in parallel. But it doesn't stop at looking at search results. It actually clicks on the links, parses the HTML and PDF content, reads through entire documents. According to the system documentation, these agents are navigating to dozens of websites and processing tens of thousands of tokens of context from each source. And if the initial information isn't sufficient or seems contradictory, it iterates. It refines its search terms and executes new loops, mimicking what researchers call berry-picking information retrieval, where your understanding of what you're looking for evolves as you find new information. Finally, there's the synthesis engine. The agent takes all this retrieved data, often from 100+ sources, loads it into its massive context window, and performs cross-document analysis to create a coherent narrative with proper citations. So when we're talking about the energy cost of a deep research query versus a Google search, we're not comparing like with like. We're comparing a system that gives you a starting point versus a system that gives you a finished research report. The research I'm drawing from today includes a perfect example, a deep research task that produces a report with 60 cited references.
How much work is that really equivalent to?
This brings us to our second key insight, and this is where the story gets really fascinating. When researchers started looking at the total energy footprint, not just the AI energy consumption, but the human energy consumption it's replacing, the efficiency equation completely flips. Let's walk through the math, because this is mind-blowing. To produce a research report with 60 citations, what would a human researcher actually have to do? Studies of information retrieval behavior show that finding a single relevant, citable source typically requires multiple search queries and examining several irrelevant documents. The precision of web search is rarely 100%. A ratio of one relevant source per 3 to 5 visited pages is pretty typical. So to find 60 relevant citations, a human researcher likely has to execute 20 to 50 broad search queries, scan 200 to 300 search results, and actually read and parse 100 to 150 full documents before selecting the best 60 for their final report. In terms of discrete information retrieval actions, we're not talking about 60x the work of one search. We're talking about 150x to 200x the work. The research calls this search equivalence. Essentially, one deep research task is functionally equivalent to about 150 Google searches executed in sequence, plus all the associated reading and analysis. But here's where it gets really interesting. Let's talk about the energy cost of the human researcher. Humans are biological machines with continuous energy demands. When you factor in our metabolic rate plus the hardware we use, the energy picture changes dramatically. A human working in an office environment has a metabolic rate of about 120 watts, just from existing, thinking, and doing cognitive work. Add in a laptop, which draws 30 to 60 watts during active use, and you're looking at a human plus hardware system that consumes about 160 watts continuously. Now, how long does it take a human to produce research equivalent to what these AI agents are producing?
The research looked at academic benchmarks for literature reviews and found that even a fast freelance writer might spend 15 to 20 hours on a report of this depth and citation density. But let's be conservative and say 8 hours, one full workday. 8 hours at a 160 watts equals 1,280 watt-hours of energy consumption. Compare that to the AI agent, which consumes about 40 watt-hours for the entire task and completes it in 5 minutes. The result? The AI agent is 32 times more energy efficient than the human researcher for producing the same output.
But wait, there's more. Let's talk about the quality and completeness issue, because this is where AI really starts to shine. Humans have what psychologists call bounded rationality. We satisfies. We stop searching when we find information that's good enough rather than exhaustive. After finding 10 to 15 sources, most human researchers start to experience fatigue and cognitive overload. We also process information serially.
We can only read one document at a time, and our working memory is severely limited. AI agents, on the other hand, are driven by reward models that actually penalize incompleteness. They can parallel process information, maintaining massive context windows that allow them to hold hundreds of sources in working memory simultaneously. This is why you're seeing these reports with 60-plus citations, not because the AI is trying to show off, but because it can actually synthesize information across all those sources simultaneously without the biological limitations that constrain human researchers. The research introduces this concept called the cognitive displacement ratio, essentially measuring how many hours of human cognitive labor are displaced by 1 unit of AI compute. When you run the numbers, 1 kilowatt-hour of deep research compute saves about 200 hours of human research time. And here's something that really drives the point home. Recent benchmarks show that frontier AI models can complete tasks in minutes that human experts rate as taking 4+ hours. In systematic review screening, a staple of academic research, AI agents can screen thousands of abstracts in minutes with accuracy comparable to human reviewers, a task that typically takes humans weeks. This isn't just about efficiency, it's about the democratization of expert-level research capabilities. Think about what this means for small businesses, students, journalists, or really anyone who needs to do deep research but doesn't have access to a team of research assistants. This brings us to our third key insight, the broader implications of what we're witnessing here. We're not just talking about a more efficient way to do research. We're talking about a fundamental shift in who has access to expert-level knowledge work. And the economic implications are staggering. Let's talk dollars and cents first. A deep research task using a pro subscription might cost effectively $2 to $4 per task. Even using the most expensive API options, a comprehensive research report might cost $5 to $10 in compute tokens. Compare that to hiring a skilled researcher or analyst, who typically cost $50 to $100 per hour including overhead. An 8-hour research task costs an employer $400 to $800. The AI is roughly a 100 to 200 times cheaper for the same output. But here's what's really exciting, and this just happened. The economic barrier to this technology is collapsing even further. Models like DeepSeek R1, which offer reasoning capabilities comparable to OpenAI's most expensive models, are reducing the cost of a deep research task from $5 to literally cents. At that price point, the economic barrier to analyst-level research capabilities essentially vanishes. Think about what this means in practice. A small business owner who could never afford to hire a market research firm can now get comprehensive competitive analysis. A student working on a thesis can access research capabilities that were previously only available to academics at major universities. A journalist can do investigative research that would have required a team of researchers.
But we also need to acknowledge the broader environmental implications, and this is where things get nuanced. While the per-task efficiency of AI is dramatically superior, there's something economists call the Jevons paradox. When technology makes something more efficient, we don't just maintain the same level of usage, we dramatically increase it. Because deep research is 100 times cheaper and faster than human research, we're not going to just perform the same amount of research we did before. We're going to perform exponentially more. Organizations will start generating comprehensive research reports for decisions that previously would have warranted a 2-minute Google search. So while the intensity, the energy per task, drops dramatically, the volume is likely to skyrocket, potentially leading to a net increase in total energy consumption by data centers. This is something we need to keep an eye on as this technology proliferates. There's also the question of information quality and what some researchers are calling the hollow web. As AI agents increasingly read content generated by other AI agents, we risk creating circular reporting loops where the breadth of citations becomes illusory. But the leading platforms are already addressing this by prioritizing authoritative sources like academic journals and established news outlets.
So, let's synthesize all of this into 3 concrete takeaways that you can apply to how you think about AI and efficiency going forward. First, beware of misleading efficiency comparisons. When you see statistics about AI energy consumption, always ask, what is the AI actually replacing? The 15x comparison assumes AI queries are replacing simple Google searches, but that's not what's happening. These systems are replacing entire human workflows, hours of research, reading, and synthesis compressed into minutes. The relevant comparison is energy per completed task, not energy per technical query. Second, we're witnessing the democratization of expert-level knowledge work. This isn't just about making existing research faster. It's about giving individuals and small organizations access to research capabilities that were previously only available to large institutions with dedicated research teams. This could fundamentally reshape how information-intensive work gets done across every sector of the economy. And third, the economic and efficiency gains are so dramatic that they're going to drive massive increases in usage. Just like how cheap flight travel led to vastly more people flying, cheap AI research is going to lead to research being applied to decisions and questions that would never have warranted professional research before. This is likely a net positive for decision-making and knowledge creation, but it does mean that total AI energy consumption will probably continue growing even as per-task efficiency improves. The bottom line is this. The narrative that AI is wastefully inefficient is based on a fundamental category error. When you compare like with like, complete research tasks rather than individual technical queries, AI represents one of the most significant efficiency gains in knowledge work that we've ever seen.
Far from being an environmental disaster, these deep research agents might actually be the ultimate energy-saving devices for the information age. That's a wrap on today's deep dive into AI efficiency. I hope this has given you a completely new framework for thinking about these energy consumption debates. If this episode changed how you think about AI efficiency, I'd love to hear from you. Share your thoughts on social media and tag us at MindcastPodcast. And if you found this valuable, please subscribe and leave a review. It really helps other curious minds discover the show. Next week, we're diving into the psychology of human-AI collaboration and why the future of knowledge work isn't about replacement, but about augmentation. Until then, keep questioning the headlines and digging deeper into the stories that shape our technological future. This is Will from Mindcast. Thanks for listening, and I'll see you next time.